Hello everyone, welcome to another video session class. So in today's class we will study another name reaction that is known as Birch reduction. So let us just start. So what is Birch reduction? So that is it is the conversion of an aromatic ring to the 1,4-cyclohexadiene in presence of metal, ammonia and one alcohol. Okay, so Birch reduction of aromatic substrates with alkali metals alcohols in liquid ammonia is known as Birch reduction. So the Birch reduction is an organic reaction where aromatic rings undergo a 1,4 reduction. Okay, so in the 1 and 4th position, so you see 1 and 4th position, 1 2 3 4. So at the 1 and 4th position there will be reduction, okay, to provide unconjugated cyclohexadiene. So it is 1,4-cyclohexadiene. Okay, so here you see reduction means that is addition of hydrogen. So in the 1 and 4 position there is addition of hydrogen. See H. So ultimately the reduction take place. The reduction is conducted by sodium or lithium metal in liquid ammonia and in the presence of an alcohol. So this alcohol. So let us just see the mechanism. So mechanism here, what is happening, single electron transfer from the metal to the aromatic ring. So that metal is used as a source of electron. Okay, single electron, that means you can say radical. Okay, from the metal to the aromatic ring forming a radical anion. So that is radical anion. So let us see that there are 4 steps of reaction. So let us see step by step. So first step 1, reduction of benzene to benzene radical anion. So you see we are using ammonia, liquid ammonia along with the alkali metal. So Na or lithium, whatever, that will react with ammonia, liquid ammonia, to generate one radical ion. Okay, radical anion. That radical anion will attack the ring. Okay, so from this bond one electron will come, so it will form here. It will form, and what will happen, see, from here the electron will come here. Okay, come here. So this electron will attack this place, this electron will come here, so it is negative, 2 electron negative. Then the next, this bond electron will come here, and this bond will also break down, and 1 electron will come here. That is, it is homolytic bond fission. Okay, 1 electron is going to this side and 1 electron is coming to this side, bond electron. Okay, so here 1 electron from this side, 1 electron from this side, so another bond forms. So this is the another bond. Okay, and this electron will come here, so ultimately it will form the radical. Okay, so radical, and this bond remains same. So this bond remains same. So from this solvated electron will attack the benzene ring system to form benzene radical anion. So this is benzene radical anion. So this is anion and this is radical. Correct. The protonation of benzene radical anion. So in the next step, what will happen? This electron, proton from the alcohol will protonate the benzene radical anion. So that means this H will come out here. Okay, in this negative, H positive, and here it is negative. So ultimately, see this blue color hydrogen is coming in this one. So we are getting one hydrogen here. Okay, so ultimately the next compound is benzene radical ion. Okay, so next, reduction of the radical to an anion by the electron. So here electron from the sodium, okay, it will again attack this radical benzene radical to form anion. Okay, to form anion to an anion. Okay, that means to form an anion. Reduction of the radical to an anion, that means this reduction will take place. That means this electron will come up here, so both this electron will constitute negative charge. So ultimately we are getting this negative charge, pentadienyl anion. Okay, pentadienyl 5-dienyl anion. Then protonation of the alcohol by anion. So next, what is happening, again one alcohol will come and it will protonate this anion. Okay, benzene anion, radical anion, not radical, benzene anion or pentadienyl anion. So this electron will attract the H, or electron will go towards H to form a bond here, okay, CH bond. You see here C and this blue hydrogen, so it is forming the CH bond. So ultimately we are getting 1,4 cyclohexadiene, and along with that one we are getting NaOCH2 CH3. So CH2 CH3O, then this Na, okay. So that is the mechanism. So ultimately from your benzene ring, simple aromatic ring, we are getting 1,4 cyclohexadiene. The next application, naphthalene can be reduced to 1,4,5,8 tetrahydronaphthalene by using Birch reduction condition. So you use this Birch reduction condition. Remember, the temperature should be minus 70. That is very less temperature in minus, okay. It is in freeze condition. The temperature of the reaction should be very less. So NaNH3 liquid ethanol, okay. So we are getting this from naphthalene, we are getting 1,4,5,8 tetrahydronaphthalene. The next, another application in the Birch reduction of benzoic acid. So this is benzoic acid, benzene with carboxylic acid group. So benzoic acid, you do first the Birch reduction, then you do acid hydrolysis. So it will give the 1, 2, 3, 4, 5, 2,5, what? Okay, not 2,5, 1, 2, 3, 4, 5. So 1,4 cyclohexadiene with at the 6th position 1 carboxylic acid, okay. So next application, this protonation occurs at ortho and meta position of benzene ring in case of anisole, and thus by giving more substituted double bond. It is due to the fact that electron donating groups stabilize the radical anion at ortho and meta position. So protonation occurs at the ortho and meta position. So ortho, meta, para. So you see ortho and meta position protonation take place. Why? Because the electron donating group stabilize the radical ion at ortho and meta position, okay. So electron as this OCH3 is methoxy group is electron donating group, so it stabilize the radical anion at the ortho and meta position. So the electron donating groups deactivate the ring towards Birch reduction. So see, this is electron donating group CH3. So here you see we are using this Birch reduction reagent, okay, but there is no reaction taking place in this ring, okay, because it deactivates this CH3 and CH3, which are electron donating groups. This will deactivate the ring towards the Birch reduction reaction. So that's why ultimately the reduction is taking place at another ring, okay. So that is the case. That means if there is electron donating group in the ring, it will deactivate or it will not allow the reduction of the ring by the Birch reduction mechanism, okay. So here you see CH3 in this ring, that means there is no Birch reduction, but there is no electron donating group in this ring. So that means ultimately here the Birch reduction is taking place, okay. So that's all about the Birch reduction. So I hope you have understood. Thank you.